I'm Mary Parker, and welcome to this episode of Eureka's Sounds of Science. Ziva Abraham is the CEO and founder of MicroWrite, a consulting and training company that helps pharmaceuticals, biotechnology, and medical device companies. She is also mad about mycology, having fallen in love with fungi at an early age. She has written and edited books and articles on the topics of fungi and the prevention of contamination in clean rooms, and she is here today to talk about her career and her passions. Welcome, Ziva.
Thank you, Mary,
I'm
for the
I'm so
kind
glad
introduction.
to I'm so glad to have you here. I hope you feel welcome. So, can you, for the benefit of our listening audience, tell me about your education and your experiences before college?
Absolutely. This is something I'm never asked, so I'm going to share this for the first time. I was born in a very religious community in India where girls were married off at age anywhere between 13 to 16 years of age. But I was fortunate that my mother had admitted me in a local Anglo Indian Montessori school. Well, this Montessori school teacher somehow convinced my mother to admit me in a Zoroastrian school. Again, this is in Bombay, India.
Hmm.
And my mother agreed. School life was not fun.
I'm not actually familiar with that type of school. Could you explain a little bit what that's about?
The Montessori or the Zoroastrian?
The Zoroastrian, but we might as well explain both.
Okay, so Montessori, the Anglo Indian Montessori school is when, we had British ruling
Hmm.
India. So the mixed marriages between the Indians and the British and their progeny was called Anglo Indian.
Hmm.
So they had a lot of British customs, but they also spoke English language. It was a great school. Montessori school was great. I learned to eat with a fork and spoon, not knife, fork and spoon, and learned some basics of playing piano. Zoroastrian is the most ancient religion from Paras. Paras is Iran today. Their tenets are good thoughts, good words, good deeds,
Hmm.
and they are very prominent philanthropists in India. So Zoroastrians moved from Iran or Paras many, many years ago, but they really did advance education in India. And this school was built by Kavas Ji Jahangir, a prominent Zoroastrian and a lover of education and arts. And that is the school I went to. It was not a school that we know today. It was a girls' school. The girls were not only groomed in academia, but also as being a good housewives. So we had to learn gardening, cooking, cleaning, embroidery, sewing, handicrafts, everything. And if you fail three subjects, whether it be gardening, cleaning, and embroidery, you fail the class. It was a strict school.
Hmm.
It was very interesting. I wish there were more of those schools today.
This is a total tangent, but I can tell you, I have a whole rant prepared about how kids are not given the typical home economics classes that they used to. I mean, I never did, but it sounds like it used to be something from, sure, there would be cooking and taking care of babies and sort of that sort of thing, but they would also teach you like how to balance a checkbook, how to pay your taxes. And that's just like not something they teach in schools anymore.
I wish they did. I wish, the things we were taught, Mary, was amazing. We grew vegetables like lettuce and all that, and then we can buy it at a reduced
Hmm.
price. And then there was one bookkeeper, and we had turns in counting, did we make a profit or not make a profit?
Hmm.
And one of the things, and I'm a good cook, and one of the things we were taught in cooking was also presentation. So when you had cooking exams, you were not just judged by the taste of the food, but also the presentation.
Hmm.
You don't see that today.
Yeah, exactly. Yeah, but that's a bit of a tangent. Tell me about what school was like for you.
School was tough.
Mhm.
I could not participate in sports because I was not allowed to wear shorts from the community I was born in. Also, my school uniform was very different than all girls because I could not wear a skirt and show my legs.
Hmm.
It was not easy. It was really not easy. But as I progressed in the grades, by middle school, I knew I had to study hard and not meet the plight of getting married early. I had to fight. I had to fight all throughout, and I had to fight also to go to college.
Hmm.
Hey, but I'm glad it was a good fight I put up.
Well, I mean, we're glad you did because we're going to get into how cool some of your new work is. But in the meantime, what do you think drew your attention to fungi?
Oh, this is such a fun question. So, in 10th grade, Mary, we had a very good biology teacher, and we had to learn about, in the 10th grade, in the Zoroastrian school, learn about the life cycles of microbes. Okay. And I really got so fascinated by fungi. This fascination continues till today. For my first degree, I majored with some focus on plant pathology, right?
Hmm.
So I didn't know what I was doing. I had to fight to go to school, to college. The college was close by. I agreed, okay, I won't go far. I'll go to the closest college. They had major in botany. I took major in botany, and they had plant pathology. And that really got me even more into learning about fungi. And the more I learned, the more I was fascinated. Fungi are so versatile, aren't they?
They really are fascinating.
Their own class, their own phylum. It doesn't matter. They are beautiful,
Hmm.
very mysterious, very. That's why they keep me going till today. I'm like, every time I discover something and I say, whoa, I didn't know about this.
So it started with a 10th grade teacher, and then obviously you took some more classes, but what finally convinced you that this could be a career?
Well, so, once I completed my bachelor's in botany, I wanted to focus on microbiology, especially mycology. So, remember, I'm talking about the 70s, okay?
Mhm.
There was just one institute that offered mycology in Bombay, and I was lucky to get admission. Of course, it was a challenge on all fronts. Now I've done my bachelor's. Why am I doing my master's? And why am I going far away? It was not far away, it was half an hour train ride. And also from the university, well, I had very good grades in my bachelor's. I was a distinction student.
Mhm.
I was still not thinking about making fungi as a career, right? I was just living my passion. I was just excited about fungi. My career actually started when I aced my master's class, winning a CSIR a fellowship for PhD. CSIR fellowship is Council of Scientific and Industrial Research Fellowship. It was a lot of money. I was so excited. It was like a salary for a technician,
Uh-huh.
a senior technician.
Wow.
And that is when, yeah, it was very good money, and all the conventions were paid for. It was a very good opportunity. And this is when I knew the career path I wanted to choose, and that was mycology. So I was guided by one person in the beginning because, as I said, moving away from home was a no.
Mhm.
But this person who also knew my family said she could come to Pune and then she will get great guidance. I will guide her. And he actually encouraged me to do my research on microbial insecticides. And I worked on bacteria, some bacteria, but mainly on Bovaria bassiana and Bovaria brognatii, and a little bit on Fusarium species.
Mhm.
But as I told you, I have been very, very fortunate. So this person guided me to work at Hindustan Antibiotics, which was a very prominent antibiotic manufacturing company that used to screen for fungi and actinomycetes and had the best mycologists and microbiologists. So I was trained, and Dr. Tirumala Char, who is a world renowned mycologist, and Dr. Gopal Krishnan, both from Hindustan Antibiotics, advised and guided me.
Hmm.
But I got even luckier. This person was doing some work in conjunction with Pasteur Institute, Madame de Berzac of Pasteur Institute, France.
Hmm.
And I'll tell you a little more about her. She took great interest in my work because there was not much work done on fungi and their capability of being commercialized as microbial insecticides or pesticides.
Hmm.
Now, Madame de Berzac of Pasteur Institute, France, was a pioneer on microbial insecticides, and she was the one who actually helped commercialize Bovaricin and Bacillus thuringiensis. So I had three great teachers,
Hmm.
and they were tough on me. They were not easy on me, but they all encouraged me to work on fungi. They said, this is an unexplored field, work on fungi. But I have to tell you, those were the best years of my life. So, I must say, the research years was like riding motorbikes. You won't believe that. Going into remote fields, collecting insects with fungal growth,
Hmm.
coming to the lab, identifying them, propagating them, and testing them against pests.
Hmm. Yeah, that does sound really weirdly fun.
It was so fun. I did do a lot of mass scale spore production in biofermenters. So that's where I got first introduced into biotechnology and how to use fermenters, right?
Hmm.
But then in 1997, I moved to Israel. Now, microbial insecticides was a new field, and there were no career opportunities in my field of research.
Hmm.
So I fell into the clinical laboratory system where I worked as a clinical scientist for 12 years and then chosen as the founding director to start 12 clinical labs for Maccabi Medical for the entire south zone of Israel. I must say, if not for my manager at Kaplan Hospital, I wouldn't have been such a good microbiologist and a good contamination control microbiologist.
Hmm.
Yes.
And Kaplan was in Israel?
Yes.
Okay.
He encouraged me. Not only he taught me and I'm talking old days, okay? I'm talking 77 to whatever years, 12 years. We didn't have, so I was on the evaluation committee of the first microbial AMS system. I don't know how many people know about it. This was the first automated microbial identification system
Hmm.
built by McDonnell Douglas for NASA. And BioMaria wanted to purchase it for clinical labs, and they chose 11 prominent clinical labs in the world. And my boss's lab was one, and he put me on that project. He encouraged me to explore new technologies when we discovered HIV, the ELISA systems, and all. But again, I owe a lot to my mentors.
Hmm. Yeah. So this type of mycology is mostly geared towards keeping fungi away from patients, right? Off of patients, off of equipment, tracing where they come from.
Yes, so clinical mycology is much different from pharmaceutical mycology. Clinical mycology, it's
Hmm.
very limited there to. But I'm glad that you're asking this question, Mary. I must talk about this. So, in the beginning, we only talked about clinical mycology. The samples we got were all clinical mycology, trichophyton, microsporum, things like that.
Hmm.
But with the onset of HIV, we started seeing patients get fungal pneumonia,
Mm.
and the whole field of clinical mycology changed. That was a great opportunity for me to learn how fungi evolved and how they attack. The first one to be discovered from HIV patients was Pneumocystis carinii. We don't even talk about it.
Hmm.
We literally had to develop media to recover this. But in 70s, aspergillosis was a lung disease of the pigeons. That's all we knew.
Hmm.
Okay. Yeah, it doesn't affect humans. With the onset of HIV, we started seeing aspergillus. It started with Pneumocystis carinii, then aspergillus, and then some of the zygomycosis fungi. So this has always been fascinating to me, how these microorganisms, especially fungi, evolve right? And how they attack. And I think in our industry, there's a gap in understanding how fungi evolve and how they adapt
Hmm.
and how they infect. And this is a gap that I think someday I want to write about and talk more about, that we don't have an infective dose in fungi. We say you need 10 of E. coli or 100 of Shigella or 10 to 5 of Bacillus cereus. No, you could have one mold and the person is really immunocompromised. That one mold can then take root and spread.
Hmm. Yeah, absolutely.
It was a very fascinating time from 77 till I came to US in 1992.
And then you moved to the US in 92. How'd you get from there to founding your business, MicroRite?
Ah, that's interesting. It's the American dream, right? Everybody should be on in 1992. So, by the time I left, I was the founding director of medical lab systems for South Zone of Israel and a chauffeur from work.
Nice.
But there were 12 labs, and some of the labs were remote, and I had to manage the labs. And, even during wars,
Hmm.
we all get recruited, and I had to manage and all the labs for emergency operations. I don't know. I was offered a bigger job, but I just wanted to explore, and it looks like it's in my nature. Came to US in 1992, right?
Hmm.
It was a tough move.
Hmm.
It was a tough move. I had to start as a temp worker after having a chauffeur. But that didn't deter me, because I worked as a operations manager for clinical lab system, which today is Quest Laboratory. It used to be Corning, then MetWest, then Unilab, then Quest. And I used to manage all the departments. But at some point in the clinical laboratory system here in US, they decided to reduce the number of technologists and hire more analysts, means machine operators. And I did not like that, because we had lost the knowledge base. So I started working in the pharma industry, medical device industries. So I worked for about 5 companies as a contractor or a full time employee. And that's when I realized that there's a gap in understanding microbial contamination, its effect on the patients, and contamination control in general. So in 1998, I made this bold move. I quit my job. I was at Biolog, working at Biolog. I quit my job, took 6 months off, and said, I really want people to look at contamination seriously, because there are a lot of immunocompromised patients and microorganisms are evolving. So, what should my company look like, right? I started this company in 1998 as a single microbiology consultant. I was not happy. I knew that there is more to contamination control than microbiology alone. So then I started building a team of people, and it was slow progression, I have to tell you. And it took me about 10 years to have this whole team, and I'm telling you, it never feels like work today. It's always a learning. Every day it's a learning opportunity for all of us. So these were all high level experts in facility design, computational fluid dynamics, airflow visualization, validation, microbiology, quality. And the goal was to provide holistic solution for manufacturing contamination free medical products.
Right.
They have been involved in drafting many of the standards that we use in the industry, such as the ISO 14640 for series of clean room standards and sterilization standards. So the goal was that together we can provide a holistic and proactive approach to contamination control than a reactive approach to remediating contamination. I hope that makes sense.
Yeah, absolutely. And it also kind of gets in nicely to the next part of what I want to talk about, which is like some of your pet peeves with facilities design. I believe that you had some case studies in your book. I was wondering if we could go over those.
So I'm going to tell you my favorite one. That is the most common. in most of the cases where companies get warning letters or 483 observations, have failures, sterility failures, or even data integrity issues. At Microwrite, we call it stealing from Peter to pay Paul. Let me explain this to you.
Yes, please.
So, you have the RAB system. We get very excited about technology, but we don't think through it.
Hmm.
We don't think through it. And we depend upon the suppliers to give us, but we have to decide what we want and understand the effect, the design of the barrier system, the design of the clean room, and their integration. These are not two separate units, they affect each other. By barrier systems, I mean your RABs, open RABs, closed RABs, active RABs, passive RABs, your isolators, right?
Hmm.
So majority of the time we are seeing either there are open RABs, that means they don't have their own HEPA filters, but we see closed RABs, right? They have air inlet from the grade B area. So the air that is supposed to clear the grade B area is sucked directly into the air inlet of the RAB.
Mm.
Now, I want you to visualize this, okay? It comes out, woof, it goes into the RAB
Hmm.
inlet, right? What happens? What happens to grade B area? It's starved of air.
Oh, yeah.
Does that make sense?
Yeah.
Yeah?
Yeah, I think so.
Now, just imagine that you have this RABs, right? The air is sucked in, the air comes down, right? Comes down
Right.
from the RABs, and it is supposed to go to the return duct. But that inlet is so powerful, it's sucking so bad that the air, part of the air goes into the
Mm.
wall returns of the grade B area. Most of it is going over the operator back to the RABS inlet because the suction is so powerful.
Okay.
What is, understand what is happening? So this air came down, touched the floor, picked up the dirt from the floor, contaminated the person, went back into the RABs. Now, this contaminated person is going to do aseptic operations. Any surprise that you get failures?
Right. Yeah. That makes perfect sense.
Oh yeah, it this is a very common design flaw that we see.
Hmm. So these are the sort of things that you are able to see in a facility and then advise people that have, partaken of your company, and you guys have solutions for these?
Of course. So, we have design engineers,
Mhm.
right? Our design engineer actually wrote ASHRAE's clean room design guide. We take design very seriously, including door openings, pass throughs, and everything. And today, Annex 1 2020 addresses all these because we are learning as an industry, we are learning. We also provide computational fluid dynamics. And I want you to understand that computational fluid dynamics is a preemptive tool to understand your airflows. You saw this example I gave was related to airflows,
Mhm.
right?
Mhm.
So if you do a computational computer modulation of your airflows in the design phase when it is still in blueprints, you get about 90% accuracy of or how your air is going to flow.
Mhm.
And most probably this will become a required test in ISO 14644-4, which my team is participating in. I think it will save people a lot of pain later on and trouble later on
Mhm.
if they know exactly whether the design is good and whether they should choose that equipment and go on with the construction. So, getting that preemptive or the initial look into the design, airflows, personal flows, particle generation upfront is a good, and we do that all the time. Plus, we are very well known on airflow visualization. We even built, I told you, I work with very smart people, my team. They're engineers, a lot of them. I don't talk their language, I'm learning every day. But they decided they want to develop equipment for airflow visualization that can actually map the airflows, not give false positive results. And they succeeded in doing that. And that's where we have the tracer particle generator.
Yeah. So this tool can visualize the airflow in a space that already exists, not just one that it's trying to design?
No, the CFD is for the design phase,
Okay.
and this is for the space that exists. And of course, we have microbiology. I'm a microbiologist, so I have a big team of microbiologists, and I really wanted specialized microbiologists. So what I did is I chose people who are good at compendial methods, who have worked in labs and managed labs, those who are cell therapy, those who are good at EM, disinfections, people who have developed disinfections and have worked for companies that develop disinfectants, and of course, contamination control microbiologists. It's all fun.
So it sounds like the design phase, in order to get these places to be up to code, up to keeping the contaminations as low as possible, that's like the most important phase. Yeah.
Absolutely. You design well and then you verify that design, because that saves you a lot of trouble later on. And it starts with the URS. I have a joke. I always tell people, if you don't tell the vendor, if you don't decide as a team what is your ultimate goal, how do you want to achieve the goal, and what design is best for you, the supplier is not going to do it for you. They might give you off the shelf option. And I compare it to a man coming home and the wife tells him, "Why didn't you do the dishes?" And he says, "You never told me to." This is exactly the same thing. Unless you tell the supplier exactly what your design should be, exactly how it should be integrated, they won't know.
Mhm.
So if we put effort in the design phase, verify the design by CFD, confirm the airflow by smoke study or airflow visualization, we can reduce a lot of contamination issues.
I think that'll come in handy for design, not even just for labs. I feel like people are starting to understand how airflow works a little bit more because of COVID and going into restaurants and doing air studies to see, if there's an infected person in the kitchen, how far does it go out into the dining room and vice versa. Yeah.
Yes. And I'm telling you, over these years, majority of the contamination, occasionally you will have other causes of contamination, but majority of the contamination are either airflows or personnel and material flows,
Mhm.
and mainly airflows if it is in the critical grade A, grade B areas.
So yeah, let us know the title of your book.
So this book was 4 years in the making, okay, because I wanted it in a certain way and have a certain flow, starting from case studies for people to understand these are real, these are case studies and 483, and then explaining the reasons behind these. So we start with design, CFD, airflow visualization, cleaning, so on and so forth, including static charge. The name of the book is Clean Room Contamination Prevention and Control, a practical guide to the science. I was very flattered when PDA wrote on their site, and it's still on their site, that this book has information not found anywhere else. And that was my goal, and I
Mhm.
achieved it. And I'm glad, and I'm sure people will get a lot out of it.
That's wonderful. That's a rare thing to say for any book that it has new information in it. So,
Yeah,
yeah.
it was a journey. This book was a journey.
Does your work bleed over into your own personal hobbies?
Ah, yeah.
I kind of figured.
Yeah. So, I'm a botanist, right?
Mhm.
I love plants. So, I live in San Jose, California. We don't get half an acre to an acre land. I have a 6,000 square foot lot with a 2,000 square foot house,
Mhm.
right? But I grow 22 fruit trees,
Wow.
tons of ornamentals, vegetables,
Mhm.
flowers, you name it, and they are from all over the world. So I actually treat each plant separately. Some are acid lovers, some don't like acid, some like too much nitrogen, some don't like so much nitrogen. So a lot of my botany and ecology work I use in my garden. But you'll be surprised to hear what I'm saying now. I think I'm learning more about fungi in my garden than I've ever learned.
That does make sense.
Fungi,
No, that makes perfect sense.
it does. So, you get some fungal contamination here and there, but it was such a shock for me that I was seeing this underground fungal network being used by plants to fight similar species.
Mhm. Mhm.
I dig into the ground, right? I dig into the ground. I take my manual microscope, look into it. So I'm going to give you two examples which are very, very interesting. I have Michaelia alba. It's called champa, and Michaelia champaka. One is a tree from China. You will find them in a lot of monasteries, and Champaka is from India. This is the most expensive perfume, that's what I'm told. Well, my Alba was established tree when I planted Champaka, the Indian version, about 20 feet away from the Alba.
Mhm.
Champaka was so happy, and its flowers are much more fragrant than those of Alba. And it was flowering profusely. And just one spring, it was dry. It was killed by the Alba. So you see how fungi are. They do some good work, but they also
Do
are
some
very, very,
assassinations. Yeah.
yeah, they do. It's right under, in my garden. And I thought that was an unusual case because they were across the walking path. I couldn't dig in. Well, I planted two mulberry trees. One was Pakistani mulberry, which are long and juicy, and one was Afghani mulberry, about 15 feet from each other. Now, the Afghani mulberry was much shorter, Pakistani mulberry was much juicier. To give it about 5 years, the Pakistani mulberry was sucked dry. Just one fine morning, I go there, it's all sucked dry.
Wow.
Spring, of course, there are no. So you go end of the spring, right?
Mhm.
Beginning of spring, winter, everything is dry. Anyways, it's all sticks. I start and I see the Afghani mulberry flowering, and it gives out mulberries all at the same time. And the Pakistani mulberry gave out some flowers, but they were like dried.
Mhm.
Well, it died.
Mm.
So, yes,
That's sad.
my work does bleed into my personal hobbies.
That is fascinating, but also sad for the tree.
Yep.
So, to bring it back to something you were mentioning before, what specifically for you, why do you think mentoring is so important? I know that you engage in it a lot in your own business as well.
I had such good mentors, right? Who contributed to my success. And not everybody has this opportunity. I felt this. When I came to US, I didn't do any mentoring of course I mentored my employees, but beyond my employees, I didn't mentor anybody in Israel. But when I came to the US and I started joining organizations such as American Women in Science and of course other PDA and other organizations, I realized that not everybody knows their career path, and none of us know early on, right?
Mhm.
But they don't have any opportunities to have a mentor. So I made it a mission, right, to mentor. I mentored at Stanford for many years, the grad students, postgrad students, not always technical. Sometimes you just need a helping hand.
Mhm.
Sometimes you just need encouragement. If you have gone through research and if you've gone through a PhD program, you know how hard it is. So just encourage, you will get through it. I What I really loved was mentoring young girls through American Women in Science. There was an organization called, it's still there, Expanding Your Horizon, and I mentored girls from 6th to the ninth grade. And it was not only me, we were about 52 workshop leaders. And once a year, we would take over San Jose State University, all the classes, right? And everybody, and all the grounds, and everybody, all the 52 that include industry, that include the NASA, universities, and different topics: astrology, astrobiology. I taught mycology. There could be chemistry and all that, in a fun manner,
Mhm.
in a fun manner. And we encourage girls, especially girls who did not have, and there are schools that would approach us, right, and talk to us, why they're having a challenge with certain students, and we would encourage them to send the students to the mentor this program, right?
Mhm.
and And so we had this one day of fun, and we would tell these girls, oh, do you want to be a TA? That just boost their morale and give them a little more confidence, and we would make them teachers' assistants. And it was a simple thing, experiments, looking under the microscope, doing portabella, mushroom prints, or looking at brie cheese under the microscope, and they would literally get to make their own slides and look under the microscope and talk about it. It was fun.
Mhm.
And used to have three classes in the day. The students paid about $15. They got breakfast, all the fun, little books and all that. And then they went to the classes, different classes. They chose which classes, and they had 3 years to sort of go to different classes. But during the break, we would all sit with our students, whoever wants to join, and tell them about how we got where we got today, right?
Mhm.
And that is, and those became my students and my mentees for a long time. They were young students, and they would attend the course all the time. And I realized that every year, if I see those students, they felt a little more confident about themselves.
Mhm.
But I do get a lot of new immigrants, or the student chapter of PDA, local chapter
Mhm.
in San Francisco. These students will always approach me, and I always make time on the weekend to talk to them because I have the guidance they don't have.
Mhm.
And it's not always about your path or your career. Sometimes, it's just talking to them. And one of the things I tell all these students that I mentor, and I said, a mentor doesn't is not a person who's holding your hand all the time. A mentor could be somebody you have hold in high regard, right?
Mhm.
I did that. I said I emulated my mentors.
Mhm.
If you emulate somebody you hold in high regard, you will reach there. So I think it is very important for professionals to really pass on their life experience. It's not always knowledge, their life experience. Talk about their challenges and talk about their wins, which really encourages young students that they are not alone. Everybody goes through that.
Yeah. Yeah, absolutely. Well, thank you so much for joining us on Sounds of Science. It was really wonderful talking to you and hearing about your amazing career.
Thank you for the opportunity.